Today I'm talking to students about space exploration, about planetary science, and about why space is cool and how I became a planetary scientist and how I got into the field of space. So the planetary science is an amazing field that is very multidisciplinary. So if you ask me, what do you need to know to go into planetary, I will tell you anything and everything. So you can do physics, you can do astronomy, you can do geology, you can do chemistry, you can do humanities, and you can still work in some form of space. For planetary science, like the one I work in, is generally basically geology, geophysics, physics, maths, programming, but that all to promote to get you out of your comfort zone of Earth. Earth has running water on the surface, nice warm climate, protecting magnetosphere, and it has the gravity that our bodies are accustomed to. Any other planetary body in the solar system does not have any of all of that, or any of that for that reason. So when I put these pictures there, I'm thinking about landscapes. So all the landscapes in our solar system are very different compared to our Earth. So if we have somebody looking over at Earth, they're going to see a blue marble, right? Oceans everywhere, nice atmosphere. When we look at other planetary bodies with spacecrafts and missions, we don't see blue marble. We see all shapes and sizes. But the core problem is we all originated from the same cloud of dust and gas around our star. So how we all ended up being so different? And that's pretty much the nuts and bolts of how planetary science came to be. So to study planetary science, the most sexy way of doing it is to be part of space missions. So to be part of a really expensive space mission that will go out in space and observe something or bring sample back for us to analyze. My specialty is in impact cratering. So when space is not empty and we have rocks from space occasionally hitting planetary bodies, including our Earth. So you must have heard about craters. You must have heard about how dinosaurs got extinct. So a giant rock from space hit the Gulf of Mexico and caused the global climate change that eradicated all non-avian dinosaurs. What is the whole point of space exploration? And that is, at least in this sense, from the inside aspect, what we want to know is more about interior of Mars. We want to know how Mars had evolved as a planet, because if we know how Mars had evolved as a planet, that will tell us more about how Earth had evolved as a planet. And we all want to know how we all came to be and why are we here on this planet. So in a way, accumulating the knowledge about in a solar system will tell us more about our own evolution. So I'm not the only one that does this. Just want to point that out. So at our center, we have about 30 staff and students, all PhDs mostly, working on different aspects of planetary science. So InSight is one mission we are involved with, and like OSIRIS-REx is another, which is a mission that is bringing back a sample from an asteroid called Bennu, another billion-dollar mission. We also observe the night sky looking for fireballs. Like this one here, you can't really say it really well. We also work with meteorites that we collect in Australia, but we also work with meteorites from around the world, and different aspects of macro and micro planetary science. But another thing to point out is that, have you heard about the Australian Space Agency? So, a year ago, a bit longer than that, Australia has founded its own space agency. And that's a very big deal for Australia, for any nation, really, because it now has a governing body, like US has NASA, and it has a governing body that would have a space as a portfolio. So anything that's happening in the space sector, we now have where to go to. And that's very important for any one of us who has any desires to apply their future work, future jobs in space, that there should be more room for it now. STEM skills are very important to space sector, if I can call it that way, because it not only includes science, it also includes engineering, very much so. So it includes all aspects of STEM and beyond. So if you want to be a chemist but you're interested in space, there is applications. If you want to be an engineer, absolutely. If you want to be a programmer, great. If you want to be a poet, if you want to be an artist, there is lots of inspiration you can draw from space. So I think in terms of STEM being applied and needed in the space industry, it's pretty much, spot on. It's all right then in the center for it, but also beyond STEM too. To encourage students to go into STEM-related fields, I would say follow your dreams and follow what you love. So if you think there are no jobs in the area that it interests you, you're probably wrong, because we can talk about jobs of the future and then we don't know what's coming in the future. But also learning natural sciences, for example, can be sometimes hard and frustrating. You don't want to take high-level maths if you don't need to, but maths is pretty much essential for whatever we want to do in STEM in the future. So I would just say follow what you love, but also persist and persevere when your kind of motivation is a bit low, because it happens to everybody. To all the girls out there in STEM and wanting to be in STEM fields, I just want to say to kind of follow your dreams, follow your desires, follow what best you do and what you want to do, where you see yourself next. If there are no role models in the kind of area that you want to be in, that doesn't matter, because you are the one who's going to be a role model for the next generation of people coming up. So just follow your dreams and follow what your gut feeling is saying, what you think is right, because that means zero regrets. And just stand up for yourself, and we will as well.